In this round table, we have people from all the borders in in Belgium. So instead of speaking French or Dutch and translating, we may speak simply English so that everybody can understand something. Um, we will talk about the results, the current realizations of NOMADe in the e-health domain. Let's say the inclusion of technologies like sensors, virtual reality in the domain of health. We have several participants. So Frédéric and I will be let's say, will lead the discussion, if any. Otherwise, we have several participants, as I said. The point is that we know that inclusion of technologies in health is not new, of course. It is well feasible. Sensors are now available, low-cost sensors, so it's not necessarily expensive things that can be only present in some specific centers. So we think that nowadays sensors, actually everybody who has a smartphone has a sensor in it, as an inertial measurement unit. So it's really now everybody. Sensors are everywhere. And the NOMADe project has decided to develop tools, low complexity tools, let's say, for clinicians, focused in the domain of musculoskeletal disease. We will listen to several presentations. We could start by our motion sensor. Our sensor, I mean sensor developed in the NOMADe project. Of course, the sensor is generating data, and those data should be stored and somewhere, and the sensor is able to communicate with a database, which is more than a database actually, and it will be presented also. And finally, we can have a discussion about virtual reality. So, of course, it includes sensor, but it's not the main goal. Our goal there is to develop a clinical test making use of virtual reality. After that, if we have time, we can start discussion, see our new project or whatever. So I will not be longer. Frédéric, if you want to add something, or we can let Lisbeth and her team speak.
No, I have no other things to say. Thank you for this introduction, Fabien. Maybe a first idea is to hear the presentation of Lisbeth, and then after, do you want to have some question after each presentation? Maybe it's a good way for today. And then after a general discussion when all the presentations are done. Okay.
Okay.
Thank you.
Okay, thank you. I think I have the word. I'm not sure you see my presentation because currently I still see your pictures.
Strange. I'm seeing your presentation.
You see my presentation?
Yeah.
Okay, but that's the most important thing. Then I will just present. And if something goes wrong, please let me know and then I will stop.
Okay.
Okay, so it's my honor to present on behalf of the KU Leuven Electronics team the wireless sensor system that we have been designing and developing in the frame of the NOMADe project. Now I see maybe something has going wrong or not? No?
No.
Yes, there is a black box in the middle.
Yeah, that is what I see.
We all see a black box on the presentation in the background.
Yeah, but I think it's what's popping up. It's actually what I seem to see is the Teams meeting. Okay, do you see the presentation again?
Yes.
Okay, so there's going to be 4 parts, maybe some surprise parts that I have not planned in this presentation. First, I'll give you an overview of the design, the system, and then we'll show you a short movie which also shows a little demo of the contactless sensor system. And then we'll talk about the adventures of these sensors in the NOMADe cooperation that have been traveling. And last, some further steps and of course, questions and answers. Now, I welcome everyone to ask questions if they pop up. And I also welcome the team members to answer those questions with me, because the people who have been developing the hardware and the software are much better placed to answer some of these questions, no doubt. So the overall goal of this system is that we have developed a contactless sensor system to support e-treatment and also education of physiotherapists helped by this system. I think the black box is there again, no?
No, it's okay.
No, not yet. Yeah,
come back.
now,
Come
yes.
back.
Yeah, so now it's gone again.
Mm-hmm.
Every time it pops up, I see actually then the head of Frederick and of someone else. So I will just always come back then. So as I said in the morning, very shortly, the goals of the module were to be low cost and self-calibrating, and then wireless for both communication and charging. You see here at the left, you see the internals of this system, and you see that there is the IMU inside in the first sensors that we have developed. There's a microcontroller unit where we can do some, include some intelligence. There's a battery connected to the wireless charger, and there's a Bluetooth module which does Bluetooth low energy and which connects the data, transmits the data of this sensor to the data capturing unit. So the idea is that in the future we will add other sensor modules to, for example, also monitor the muscle activity. We have already developed a prototype for that, but it's not yet in this nice integrated format as the IMU is. So we have done the functional testing, I would say, and we're working on further integration. So the data capturing unit also has some intelligent processing on board and some memory, and it can then connect to a tablet or a computer that can be connected to the cloud, and either physiotherapist is locally available and checks just the measurements, or can also do that remotely, online or offline. Everything is possible. So as said already in the introduction of this round table, it's very important and interesting that there are now a lot of low-cost sensors available with great functionalities, like these IMUs today, based on MEMS technologies. They are quite fantastic. They offer fantastic experiences in terms of they don't consume a lot of power, but they also offer a lot of interesting information. So what we are targeting is shown here in total. So it's shown that we actually want to have 3 kinds of modules. An IMU module, an EMG module, and then also module that can be used to do distance measurements. And we want to receive all of that at the data capturing unit. For the IMU module, we foresee that there could be several operational in parallel, simultaneously, that could all connect at the same time to this data capturing unit. And in total, up to 8, I think, connections can be supported to different modules. So the highest priorities has been put to have the full chain working, of course, going from a sensor module to the data capturing unit and to the tablet. And the IMU module was the one that was, I think, the highest priority in NOMADe. The others, I would say, we take as an extra bonus that we will develop in this project. And those have been realized and they are operational today. So here you see what is the prototype looking like. So this is the first prototype. As also already mentioned in the morning session, the next one will be smaller, we'll have more integration and we'll have a number of new features, but I think it's good we were quite early in developing this prototype, because at least it gives us a lot of feedback from the different partners in the project, helping us to make something that is more fit for the job. Now, we electronics people, we like to talk about the hardware involved, but of course the most interesting thing for people using the device is what do you get out of it? And interestingly, so this IMU device offers a lot of the different informations. So it gives you acceleration in 3 axes, so linear acceleration, but it also gives you roll and pitch. It gives you yaw and heading, and also gravity direction. So there's a gyroscope included as well. So that helps to define a lot of things, not only pure linear accelerations, but also angular aspects, movements, and yeah, a lot of angular parameters can be derived from this IMU. So the fact of the module, the main things as mentioned, the components are here in this dotted box. You also see that we have been using standard interfaces, I2C interface for the microcontroller unit, UART towards the Bluetooth module. So we have used as much as possible standard interfaces and standard modules so that everyone could actually also build upon it. You see we implemented the Qi charger, which is also a standard, the best known standard today for wireless charging. And by means of using this standard, actually any Qi charging pad you may have for other devices can be used also to charge these IMU modules for the NOMADE project. So also for the data capturing module, there was a prototype design. Now we call it the data capturing unit meanwhile. And so the idea there is that it can connect through all the Bluetooth modules. It can connect to the different IMU and other sensors that could be connected to this thing. So it has a USB connector to connect to a tablet or a PCB and to be charged as well. And there is an SD card where you can store the memory. All of this is centrally organized around a microcontroller unit, also a very standard one that allows us to reuse a lot of design hardware and software that was and is available. So this is basically what I had to say about the hardware, but the interesting thing, of course, is to see a little demo because it is operational. You see here a small capture of the video that I will show. If you want to have more information on the paper, this can be found in this paper that is open access, and that I think I forgot to send to the NOMADE website, but we'll definitely do that following this meeting, and where you can find more information on this specific contactless module. Now I will stop sharing for a moment, because then I can actually share the movie. I hope that's going to work as well. Just a moment. The movie that I will show is also available online. I think, I'm not 100% sure it is already available on the NOMADE website, but it is definitely available on the website of our team, and we could of course link it without a problem. I think this should be the one. I guess you see the movie now?
Yes.
Okay, then here, oops, and now you see the black box again.
Yeah.
Yeah, every time somebody answers, it seems it's clicked.
Okay.
Should we hear something?
Did you hear it? Do you hear the movie?
No.
Well, I will make it a bit louder then, because it should play. And you should hear it actually then through my microphone. I'll try again.
No.
Maybe you can enable the sharing sound of the computer.
Should I share the sound of the computer?
So the button of sharing at the top of the page, normally you have a little slider, include the sound of the computer.
Yes. I'll try again. Good tick.
Results in pain and restraints, which can strongly affect the patient, both personally and professionally. Typical examples are lower back pain, resulting from a bad posture, neck problems following sudden impact or stress, or injuries caused by a heavy work or training load. With late intervention, the disorder might worsen and the consequences might become irreversible. Some examples that cause these problems are working for a long time with a curved back. Not sitting properly on the chair. Regularly move heavy loads. A large part of the population comes in contact with these complaints. This increases the pressure on traditional consultations. Therefore, we present a multi-sensor solution to support the physiotherapist. Multiple motion sensor units can be attached to the patient's body. During a rehabilitation exercise, the orientation is collected and forwarded to the data capturing unit. From there, the data can be further sent to the physiotherapist via tablet or PC. In the future, a muscle activity sensor can also be connected with the DCU. The IMU module is equipped with a 6-axis inertial measurement unit and a lithium polymer battery. The module supports the Qi standard, which means it can be charged on every Qi-compatible charger pad. The microcontroller starts executing new instructions after pressing the wake up button. The indication that will start blinking and the module is ready to connect with the Bluetooth Low Energy. A battery management system provides all protection functions, such as overvoltage and short circuit protection. The sensor module has an autonomy of 19 hours at a sampling frequency of 25 Hz. The maximum adjustable sampling frequency is 100 Hz. The DCU can connect with maximum 6 IMU modules. The data containing the orientation can be saved on the SD card or directly sent it to the tablet. From there, the data can be stored in a database. The DCU is equipped with 3 connectors. The tablet can be connected with a female USB-A connector. The DC jack provides enough power to charge the tablet also during measurements. And last, the micro USB connector, which allows the user to communicate with the DCU through a serial monitor. How to perform a measurement. Connect the DCU to the computer. Press the wake up button. Take the sensor and place it on the body. Connect the DCU with the IMU sensor module. Calibrate the built-in inertial measurement unit. Adjust the sampling frequency and the output data format. Mount the SD card and create a new file. Finally, the measurements can be started. Perform the rehabilitation exercise imposed by the physiotherapist. End the measurement and put the IMU module back to sleep mode. Finally, the data can be analyzed. The physiotherapist can check whether his patients have performed the exercises properly.
Okay. So this was a little movie that we can also make available from the website, of course, and that just shows the insights of all the modules and the design, and also a little demo of how to operate it. And I think the very promising thing for us, which makes us very happy, is that it is operational at other sites of the NOMADe, that I think is even more rewarding for us than being able to operate it ourselves.
Mm-hmm.
So this is indeed what has been done further on. So the sensor solutions have been sent to the partners. They have arrived at the partners, including documentation and some software updates, some of them remotely, some of them have been sent back and then coming in the office in the lab in Ghent again. So if you see my pointer, this is our building, and that's where we let them escape. We're glad to always receive the messages of the partners telling us, yes, the things have arrived, because you never know, it takes a bit more time, I think, for our administration to get things out, and it might also be more difficult for people to receive them if you're not every day in the lab. So we're always happy to hear that a sensor module or a system has arrived. So what has happened is that 3 sets of sensors have been sent, consisting of 4 sensors and a DCU. And while we first, of course, had to duplicate it, it's not just copy paste as you could do in software. In hardware, it always requires soldering and making sure we do some tests on each of the sets. So the 3 teams that have received these and also, to the best of our knowledge and based on the feedback, also we're able to work with them, were in Valenciennes, in Reims, and in La Louvière. And there is a manual, the quick startup procedure, available online. There was feedback gathered both on the software and also on the hardware. So things we changed already is that we enable to have access to the raw sensor data, because the IMU itself can do some pre-calculations, but clearly sometimes in research you don't want to see the process data, you want to see the raw data. So that has been enabled. And there was a question whether it was possible to calculate angles between sensors, which we understand makes a lot of sense or brings a lot of interesting information for some movements, and that has been provided as well. I must say there are some other questions that we also consider relevant, and that is not possible to support in the current version, but that we really take as an important requirement for the next version. For example, the sampling frequency is something we started with. Also, when we started the project, we thought this was a good starting. We now understand that sometimes people would prefer to have an even higher sampling rate, and that will be enabled in the future. So experiments have been ongoing. We have been receiving some picture material showing that. And that indeed makes us happy. It was also very interesting to hear how these low-cost sensors perform with respect to the ground truth that is available in these expert labs. And we were very lucky to still, just before everything went in lockdown, have a visit to one of the partners that helped us a lot to understand the actual problems and also understand what is possible in these research labs. And I hope we can get back to that more face-to-face cooperation soon, so that we can at least have some meeting together and gather more feedback, and also maybe come with the next sensor system that could potentially even be better. So I think that is the next one. This is our, of course, specifically on the contactless sensor system. We want to extend it and also enhance it. So the extension mostly is on the EMG sensor, where the concept is validated on the prototype, and we want to realize the module in the same kind of form factor as for the IMU module. We have mentioned other sensors, but there I would say these would be nice to have. We will have some master thesis project working on them. We cannot guarantee, given the number of resources we have and the phase in the project, that all of them will be at the same level as the IMU model, but at least we will see what is possible and get some feedback on whether this distance measurement, for example, is something that could be easily integrated. The integration itself, we of course dream of a module that is still much smaller and less visible, but maybe also much more practical still in the future if patients would want to wear it for a longer time. And therefore, instead of using an off-the-shelf development module for the Bluetooth low energy connection, Jona has been working on the chip itself with an antenna, so it is more own design there. So you have less to rely on, but it's lower cost and it's smaller, and it allows to go for smaller form factor. So this takes more time. But in the meantime, since already the other module is there and operational, this is time I think we can spend for the last phase of the project. And we hope that this novel design, it has a number of advantages, and Jona and Jarna have been investigating in a very, I would say, ambitious way. How could we further and further reduce the form factor and the price while still keeping the same functionality? And we hope that new version will be even more convenient. Now, of course, next to the integration functionality, there's user feedback that to some extent also addresses software and calculations, post-calculations. Now that we have the full link to the tablet, and also then from the tablet further on into the cloud or whatever processing capabilities, that is not difficult anymore. It's a matter of making sure we have the correct algorithms and that we can implement these algorithms so that what you get out of the measurements probably is also more meaningful. This is what I had prepared. Thanks a lot for your interest. Thank you for working with those sensors and welcoming them in your lab. And please let us know if you have any questions or if you would welcome a sensor experiment. So as said, we can always duplicate sensors. We hope that we can do that also for the new ones. It's always a manual effort, so we can't just say, if you ask us, that we'll have it available in the next days. But if people say we really would like to have some more devices, then we can discuss whether the already available design should be duplicated or whether it makes more sense to wait for the new ones to be duplicated. So I open the floor to questions.
Thank you very much, Lisbeth. Is there any question for Lisbeth?
Or for the team?
Yes, I have one. Hello, Lisbeth.
Hello,
everybody. I had, it's more a feedback, but also kind of
feedback
a question.
is very welcome, yeah.
We experience a problem with the Bluetooth connection, and we don't know why. We don't know the reason of this disconnection problem. It appears that when the sensor is in the back of the subject and the subject is looking at the DCU, the connection is slower than when the sensor is in front of the DCU. We have the feeling that the Bluetooth doesn't pass through the body easily. And it's something that we know about Bluetooth. There's a problem with passing through flesh.
Yeah, it should not pass through the body, but it should go around the person. If it's in a further distance, that's typically what happens. But if it's very close, if it's on your body and the DCU is on the other side, actually that makes a lot of sense from a propagation point of view. So yeah, the simple solution would be to make sure you put the DCU in another place. Another solution could be that we foresee that there is a kind of repeater system, but I think that could be quite complicated. So it's from a telecommunication wireless propagation aspect. It's not a surprise, I would say. And I think if you are at the side, if the DCU is if the sensor is in the back and the DCU is somewhere on the side, it should still receive.
Yes. Yeah.
But if it's really if your body is directly in between. And I would say if there is another body in between, but the other body is a few meters from the module, it should also not be a problem. But if you have the sensor on the body and the body is in between, I can imagine it gives a problem. Okay. We have not done that kind of stress testing, I think. Is that correct, Jona or Jarne? Correct me if I'm wrong.
No, we didn't do any tests about that. What we gonna do now with the new version of the DCU is using an external antenna so that we have a higher gain. So that will also reduce your problem.
Yeah, but it's very good feedback because indeed it can be. Well, we already thinking about an external antenna, but it could make this even more important to make sure we have an antenna with a good gain that could solve the problem.
Yeah, or maybe some documentation information on please don't be closer than 1 meter from the DCU because your body will block completely the possibility. Because right now we are doing this test where people basically they turn on themselves with eyes closed. So there's a time it has to happen where the DCU is opposed to the...
But it's actually an interesting problem. Maybe Jarne and Jona, one other thing we could do is considering whether we could receive on two DCUs at the same time. If we do a diversity at the DCU side, and we could have, for example, 2 antennas connected to the DCU and one could be placed at some distance, maybe we can solve that problem as well.
To me that seems a bit complicated. What will be possible with the new version of the sensor is we can increase the output power, so there will be a higher chance that the radio waves will pass through the body and still get received by, for example, 1 DCU.
Yeah, let's try that experimentally as well, Jona. That would be a good idea.
Yeah.
Okay.
Monsieur Bartholomé, il y avait une question aussi.
Oui, merci. I know that it's not the option at the beginning, but this is for as it is conceived now, it's more for active testing. I mean, like you have someone in your cabinet and then you want to make some exercise with him. Do you think it could be possible to have a longer term follow-up of the patient with your device, maybe with a recording station on the patient too, like for more like in a real life situation, monitoring of the movement of the patient? That is first question, and the second one is also a bit out of the scope, but we like also to measure the abnormal movements like shaking and things like that. And do you think that your device is able to capture shaking?
Yeah, I think for the first question, it definitely should be possible to also have longer term measurements. I don't know what is the standalone time by heart, but I think it could work for several hours before being recharged. But I'm going to ask Jona or Jarne to give the exact number.
Yeah,
okay, that's interesting. Yeah,
it really depends on the current consumption when it is measuring at the moment. So if it is, for instance, 10 milliamps, and we have now a battery of 250 milliamp hour, so then you can calculate that it will work for around a day, but then the battery will be empty. So,
yeah. So, but it could definitely be dimensioned so that for a full day, the measurements could go on. Currently, the data is not being stored on the module, but is stored on the DCU. So it would mean you somehow need to stay in the surroundings of the DCU. But yeah, that could be considered in different ways how to potentially solve that if that would be a problem.
Could you imagine that your phone would be the DCU?
Yep. Actually, we have considered that definitely. that the IMU could be going immediately to the phone as well. But yeah, at that time, we thought to avoid it in the first instance. But also there, maybe Jona or Jarno could comment.
With a new module, from my part, it's definitely possible to set up a connection with your phone. But then if you would be implementing that, we have to write an application on your phone that decodes the data, because now we're sending the data in a special format to the DCU, and now the phone doesn't understand that format. And also for changing settings, everything we've made up until now is for communicating with the DCU and not with your phone.
Yeah, but even, Jona, if the point would only be to receive the data and afterwards to make the data available again, not on the phone, but to another device, just to use the phone as a kind of intermediate DCU to store the data.
Yeah, because that avoids that. So the people that just have their phone, they may have 1 or 2 modules on themselves, and then at the end of the day, the data is on the phone, and then you can get it back from there, even if you can't use it to make any change, because the idea is more like a recording device.
Yeah.
And then you come back to the consultation, and then the physiotherapist or the medical team, they can have a look on it. And what about the frequency for the shaking? You were talking about it.
Yeah, I think it's not a problem. I think the IMU can do that, and actually it's a matter of then transmitting and sampling of the data. But I would expect that the IMU, or at least some IMUs, could do that. But we have not specifically checked shaking, I think, unless Jona, you have done so.
If you're not shaking above 225 hertz, it should be okay.
Yeah, but that's quite a lot, I think.
Yeah, that's already a lot.
Yeah, it's mainly amplitudes that may be the limit, and what is the what are the, in millimeters, the detections?
The sensitivity.
Yeah, the sensitivity.
But it's something that we didn't make changeable in the first version, and that we had a meeting with Matthias. So something that we also will take in mind to make that adjustable in the new version, that you could change the sensitivity. I think it's normally 2 plus minus 2G for the accelerometer at the minimum, and at the maximum it's plus minus 16G. So
yeah, that's right.
Okay, that's interesting. I don't know if you've seen the article in Science Translation Medicine about the use of smartwatch for Parkinson's disease, for example. That was quite interesting. So I was wondering, could do something like that. Okay, thank you very much. Sorry for interrupting.
Before we move to the next talk, Thomas and Paul, you had some question?
Yeah, yes. The question about it. It was the same question that others. It's the connectivity of the sensors. I saw that when we use sensor more than 8 meters, we lose the communication between the DCU and the sensor. Of course, when people turn around, of course, we lose quickly the connectivity, less than approximately 4 meters or less. Then when we will use the sensor for day activities, the problem is there, I think. But I heard that it will be perhaps in the future possible to use a smartphone like a DCU. Then if the smartphone is with the people, there is no problem, because everybody takes his smartphone with him. Then I think it's a good idea to go in this direction. Other thing, I lose also sometimes, more than sometimes, data and sensor when I use 100 Hertz. is this problem resolved or not?
No.
It's because when we use intelligence, artificial intelligence, with the test we use for 60 seconds, we get 6,000 data in one column, and it's just enough for intelligence, artificial intelligence. If I have to use 50 Hertz, I think it's more difficult. And the other thing, if I want to get 6,000 data, I need to do my test 2 minutes. It's too much for a patient. Then I'm there.
Paul, if I can correct you
Yes.
about the artificial intelligence, we can the limit of computation for artificial intelligence is not the acquisition frequency. For example, 100 hertz. It's more the number of subjects
in the sample. Okay.
Yes, it's the number of sample matter more than the frequency. So we can go to 50 hertz for example.
Okay.
It's not a problem.
Okay, and I have, of course, I will need 3 set of sensor and DCU because we will begin in the following academic year research in 3 different hospitals. That we plan to do that, and we need, of course, 3 data set and 3 data acquisition sets.
Okay. How many sensors do you need for each platform?
We will use 4 EMU and of course 1 DCU for each.
Yeah, okay.
For 4 EMU.
Jarne, could you make that 5 then, so that we also get one to play with? Thank you.
Yes.
Thomas, finally?
Yes. Yeah. I have quite a few questions actually, but I won't take too much time. First, thank you for your presentation, and thank you for providing your work on GitHub. My first question is the version on GitHub the up-to-date one? And my second question is, well, you talked about sampling rates and using IMUs in parallel. Is the data rate limit of Bluetooth Low Energy, is it going to be a problem in order to increase the sampling rate of the system, or is there enough headroom to increase the number of samples?
There is definitely enough headroom in the data rate. It's the main challenge is in the synchronization.
Yeah.
And there, I think Jona and Sarah, who is on holiday this week, have been working also on a synchronization solution such that that this can be resolved. Jona, am I too simplistic? Maybe I'm too. I always see things simple, but I think this has been considered, and it's the synchronization is a challenge, but it's going to be resolved, right?
Yeah, sure.
Yeah.
So we also make sure that the synchronization doesn't generate a lot of overhead for the Bluetooth packets.
Yeah. So that's actually done. You have a synchronization protocol running currently on the system.
Well, some things are for the next version.
Okay.
I didn't answer the first question, of course, on whether the version on GitHub is actually the last one. I would expect so, but
okay.
I don't know. Jarne or Jona, did we update the GitHub or?
No, it's just the first version. The new versions will be available if.
Yeah, the new version is not yet there, of course.
Yeah.
Because if you're not sure it works, it could be a lot of hassle that you start working with a version that is not yet.
Yeah.
But if you would like to have an insight before we freeze it, you can always send us a message, of course.
Okay, yeah, great. And I had actually another question about the DCU. So I see you use an STM32 microcontroller on it. Is there a possibility to make it a USB HID device instead of using serial communication?
I did not complete it. So what was the question? Is there a possibility to make it what kind of device?
A USB HID. So you are using a serial communication between the DCU and the computer currently, but I think that a lot of STM32 microcontrollers are able to actually be real USB devices. So is it the case with the one you used or not, or will it be complicated to do that?
It is possible, but our approach is now to connect the DCU with the tablet. So yeah.
Okay.
I think there has been quite some effort in making this protocol work. So I think another protocol is not impossible, but it might be very time consuming and not necessarily contributing to the aim of this project. So
that's because I'm seeing another application for it in my head. So with the work that Wesley is doing in VR, if the device will be able to be a USB HID, you could integrate it directly into Unity and use it to increase the experience in virtual reality.
We can take note of it, and because we make a list somewhere on a box folder we share in the team of the wish list, and some things we put in essential and some we put in nice to have and some we put in easy and some in very difficult. So we will put it on the list and we will see in which part of the system of the list it ends up. But we will sure take note of it, that it could be an asset for you.
Okay, thank you.
Thank you. I think we can move to the next speaker, Philippe and his team. Thomas et Paul, vous pouvez abaisser vos mains, comme ça on ne confond plus.
Fabien, could you make the PC of... it's okay.
Yeah, you have the right. Yeah,
it's Mathieu. We're using Mathieu, his PC, and I speak through my PC. Thank you very much for joining us. I was hoping that there would be a lot of listeners, and indeed it's true for a technical thing. So we've titled this one a framework for medical applications combining a database, an Android app, and wireless body sensors. The DCU is missing, but it's included in the body sensors, of course. The outline. Let's first introduce the problem and the proposed solution and some additional requirements. Then we will take a look at the two remaining parts of the framework. We've already discussed DCU and sensors. So we're going to discuss the app and the database, and then the next steps, basic or analysis without basic of measurement data, and testing for accuracy, robustness, usability, etc. And then there's, of course, time for not so much for conclusions, but for questions. Okay, so what we need is, in fact, a complete system. We develop technology, we do experiments first, and when it's in a later stadium, we do clinical trials. Then we need to analyze the data, and the results are then transferred. We will be using, as you've seen already, different sensor types. We have different test setups with ranging number of sensors and combinations, different goals of the tests. We get input from different questionnaire systems. We are testing, of course, different persons. We are doing multiple tests, regular way. And in the end, we need to analyze everything together. And well, the whole thing is really very heterogeneous. So what we need, in fact, is to integrate. What we try to do is to integrate everything in one single database where all the data is inside. Also, the setup. This isn't mentioned here. The setup of it's more or less mentioned. The setup of the experiment itself. So this is what we engaged for, in fact, and the proposed solution is this one. As we mentioned, I'm going to change a little bit the microphone to hope it's better. three main components: the data capturing unit, the Android tablet or smartphone, and then database and web services somewhere in the cloud. The first part was the discussion of the previous 40 minutes. We install sensors and DCU, different types. The next step is we configure the setup, the experiment, by swiping the components in an app and applying everything. So you can swipe the components, for example, the IMUs in this case, on the body of the, let me call it, patient. You can configure the instruments. Normally you do this only once and you save a setup. It's not the idea that you do this every time, but that you reuse existing setups. And then in principle, you run the measurements, meaning you are streaming the data that is coming from the sensors through the DCU. This is a cabled connection, USB. We'll come back on this in a second. We stream through the tablet to the database. In the meantime, you get a live view on the tablet, and as the typical tests until now that we've seen are very short, you are able to see in the live view, in fact, the whole test. And in the meantime, it's being, they're telling me here to change the microphone. Is this better? Okay. So running measurements, storing data in the cloud, you get a live view. And in the meantime, you are also, the live view is here, sorry. And in the meantime, you are also filling in questionnaires on the Android tablet that we already discussed, or on your smartphone or whatever. I'm looking to my neighbor to hear if the sound is okay. Is it? It's not okay. Is this better? It's too quiet. That's not disturbing.
Yeah, the sound is better now.
Okay, then we keep it like this. I'm not going to move anymore. Where were we? We are running experiments. We are filling in questionnaires, and in the end, you still need to analyze the data, which is all together in the database somewhere in the cloud. The cloud, by the way, is in a village near Ghent. It's in Drongen. Some additional requirements, as they are clinical trials. There is pseudonymization of the persons involved. There is, of course, authentication upon login. There is secure and robust communication to the cloud. We included roaming and buffering. There's, of course, flexible graphic configuration on off-the-shelf Android devices, and we can do a quick but detailed analysis. I'm leaving behind the word first, and reporting in MATLAB live scripts. And if you want to combine over different patients with queries on their medical conditions, then of course you need to go into the database. In the end, we should have a powerful, flexible system for clinical trials and a workflow that includes pseudonymization. We're not going to go into all the details of each of the points, but maybe from the viewpoint of the clinical trials, the last point here, the pseudonymization, is an interesting one. This is the user flow for the patient or end user, if you want. There is a very, very, very small part on paper, and that paper is less than 1 page. And it's the only place where you fill in the actual name and the ID card number of the end user, of the patient. And you assign, typically a medical doctor assigns a patient ID, a number. Numbers that we have provided, a list that you can choose from. That's the only place where the name appears. After that, everything is electronic. You have login an Android app with a pseudonymized patient ID, and the only thing present in the cloud database is the ID itself. In the green part here, I'm going to use the mouse. We have here the enrollment, which is a questionnaire that is filled in the Android app. It's one of the famous questionnaires, already famous questionnaires of Paul. Very long ones. You fill in the enrollment of the end user, and then you go to the experiments, which combines of the diary of the examination, which is another questionnaire, and then the actual measurements existing of the setup, the measurement itself, and then afterwards you can analyze everything. So this guarantees, in fact, that there are no names. Everything is pseudonymized, excuse me, in the database. Maybe it's a good idea to show 2 short movies on filling in the questionnaires, and Mathieu is going to give some comments with it. I think he's nodding, so it should be correct.
So hello everyone. So here is a little example of how to fill in a questionnaire. So here you have the 3 questionnaires, and I'm taking the first one. Then you can choose to fill the questionnaire in for yourself, and some users have the permissions to fill in for someone else. And so here we can go to the first question, and there are a few different kind of question types. So this one is an open question where you just can fill in some details. And there are also questions where you can select one answer, or questions where you can select multiple answers. So this one is also, I'm going a little bit too fast here. And then here you can fill in scores using a drag button. And then the next type is a body chart, and here you can draw 3 sides. So you can point where the pain is, and you can the colors are for the different levels of pain, and then you can also have pins and needles and normal pain. And at the end of the questionnaire, so this is a short one, you get an overview, and then you can submit your answers to the server, and then it's stored in the server. And then we can go and take a look at the answers. So it's also in the app. Here we have a few examples. So, and it looks a little bit the same like when you're filling in the questionnaire at the end. It's just an overview of your answers. And you can also download a PDF file of the empty questionnaire and the filled-in questionnaire. And now I'm going to give the word back to Philippe.
Thank you. So let's move then to the next part, the 2 remaining components of the NOMADE framework, the app and the database. So let's take a look again. Most things you've already seen, but it's good to recapitulate a little bit. What are the main tasks of the Android device? Where it's filling in and viewing questionnaires, creating also new measurement setups. You saw the login. This is creating a measurement setup, as there are instruments to be placed. The app is also taking care of the data stream with the CPU and of the TCP data stream with the cloud database. In the meantime, it's doing live visualization. And well, let's say for the engineering part, we hide that for the normal, between brackets, users. There's developer information for debugging, emulating data streams for server testing, etc. This is how the live view looks like, but not live screenshot. There was a little bit of talk about the data stream and the sample rate. So what we did as design, the data stream from the DCU to the Android device is over a USB cable. And we send the data every 20 milliseconds. That is the base frequency, so 50 Hertz. But to enable higher sample rates, we put oversampling. So we are putting multiple samples in one message transferred over the USB. And currently it's being tested at double oversampling, so 100 Hertz. If we would go a lot quicker, we need to estimate, by the way, the number of sensors and the oversampling rate, so that we are certain that we can keep with that we have enough bytes in our Telegram to fit everything. We need to think about it a little bit. So that is the cyclic data stream. The acyclic or acyclic data stream is for commands and responses between the DCU and the Android device. To keep track of all the messages, we increment the cycle counter during each message. So if something is missed, we know it. Between Android device and cloud database, we are keeping the same rhythm every 20 milliseconds for the cyclic data, and the acyclic messages are here questionnaire setups, etc. Communication from the Android device, from the tablet or your smartphone or whatever, is either via Wi-Fi or 4G mobile data. The system has had extensive testing in another project, and there we took the habit of using mobile data. Even for very long experiments, it proved to be the best. But the roaming is quite okay. Maybe something on that robustness. So we are in fact looking at the most delicate connection, which is the wireless connection between the Android device and the cloud database, which is Wi-Fi or 4G. So what we do in fact is we have a 5-minute circular buffer where we keep the measurements running, and every 1500 messages, every block of 1500 messages in the database is acknowledged. If one of them is missing because we have the cycle counters, we ask back, the database is asking back the Android device, could you still give me that particular one? We can't, of course, give a sample that we didn't receive in the first place from the DCU, but that seems logic. Until now, everything goes very well without oversampling. During oversampling here and there, we see small holes in the, but not many. We checked while you were discussing it, absolutely not many, but here and there one is lost. Maybe we need to do a measurement on the USB connection to see how the timing is there. It can reveal a lot of things. The authentication I'm not going to discuss, we can do that later if you want. Maybe 2 demonstrations still for the moment, configuring a measurement setup and then also measuring, and you will see a live view, I think, of Sarah shaking one of the IMUs.
So in the first movie, I'm going to show a small example of a measurement setup. So you can choose to create a new setup. You have to give it a name, of course. And then you can also fill in a hardware ID and a version. That's not, for the moment, it's not very important. So I'm just going to take one. So, and then you get this. So this, it's the same as in the presentation, but empty. And so now I can add the instrument. So we need a real-time clock, so that we can put the measure. That we can situate the measurement in time, and we can also add a wireless IMU. And then the wireless IMU needs to be placed somewhere on the body. For the moment, the locations on the body can still be we can add more locations if you want. So then you can save the changes. I'm skipping the small details, so you also normally have to fill in the Bluetooth MAC addresses and so. And then if everything is set up, we can connect to the DCU. So here I'm connecting the tablet to the DCU, and then Sarah is turning on the IMU sensor. And then I'm here, so that's the screen of the tablet. I'm setting up the communication, and I'm starting a stream, but it's a stream without the data going to the database. So, and here we have a live view of the values coming from the IMU. And we can also display it in a graph. So you can see it moving. So I'm going to give the word back to Philip now.
Okay, thank you. Next point is then the next steps, but that is more a chronological order because in fact we already have it. So all the measurement data is now in the database. The setups are inside. The measurement list is inside. All the basic properties are in the app and in the database. In the database itself, we have the measurements. We have the questionnaires. Don't forget that this is still a medical clinical trial. We have the questionnaires, the answers, and everything is in fact available to data analysts via read-only queries. But that is not for the normal end user, let's say. So what we did, a bit of experience from other projects, is also that we provide in fact a MATLAB live script that accesses all that data, measurement data, I should say, and it processes it with a few clicks. We could in fact make it one click if everything would be fixed, but we leave you some options to test. This is something that as the connection came live, I think 2 weeks ago between the DCU and the tablet, or became fully live, let me put it like that. After that, we inserted quickly a number of things. What we do in the live script now, we will show you one of the measurements. What we do in the live script now is just displaying the measurement, but maybe we will show you to give you an idea, an HTML file or an export of a result from another measurement, another type of measurement. Yeah, I know. Are you commenting on this? Okay, then I'm going to put it a little bit bigger. So in fact, you need to get in the live script, you choose one of the measurements that are in the database, you get the full list. We took here measurement ID, measurement 88. So we put this in, it's more for us, the timing, etc. So when the measurement is in, you are starting the, in fact, automatic analysis. Here it's only displaying, so you can see here the measurements that are inside the database from the IMU, the different types, the real-time clock also. We didn't do anything for the moment because we are waiting for the algorithms to be defined. For the moment, I think we already received, but we didn't test it yet. The entropy, we suggested, as we heard it from other researchers, the normalized jerk score also. It's something that we could take a look at, but we are listening to what you want us to do with the IMUs one by one, or maybe even combined. If the measurements are really synchronized, it could make sense. Maybe we can give you an idea of another HTML while Mathieu is switching. I could tell you it's already switched and it's already bigger. Thank you. So the top is the same, of course. You get measurements from a database. This is from another project. We took here a slightly longer measurement, I think, but you can still see that all the extraction and calculation is very short. We can cut in time for the analysis. For example, if you want to select the time range for the, in this case, the normalized jerk score, you can simply say we are starting here, we are ending there. I'm going to skip this for the ones that want to have a bit of fun. This is the formula for the normalized jerk score. You get, in this case, these are measurements done on a powered wheelchair. So you get here the joystick measurements, the deflection pattern of the joystick, the heat maps, and the filtered and the non-filtered data. You get detailed heat maps. It's all configurable by the end user. You don't need to program it. And then you get the results in time also, as a function of time also, of course. And then I think here we see the calculation of the joystick path length, the cumulative joystick path length, and this is the instantaneous change. So this is an indication on how much was it, how long, literally how long was the manipulation over the test. And then for the, I'm going to see a little bit further, the normalized jerk score is also being calculated. There are also IMUs in this measurement, so you can see them here. As we are moving around a lot, we have a GPS that you can turn on or not turn on. It's an instrument that you can use or not use. If you use it, you are losing a little bit your the effect of the pseudonymization, because the GPS will tell you in which house you are driving around with your wheelchair. So you need to be careful with this one. And in the end, we even see where you have been driving. This is a test done in a UK hospital. So they have been driving to their parking lot, apparently in the buildings, out of the buildings. And you can also see that normally, as we test here also in elevators and so, the roaming is and the roaming combined with the internal buffering that we showed you is quite okay. And here you still get, I think, some information from other sensors, software sensors, and then also distance sensors. In the end, this is something I didn't mention yet. It was also in the other one. You can have two sources of the data. The data is in the database. You need to extract it at least once. But then you can save that once you extract it in the live script. One option is to save it as an M object, and then you're saving it on your own PC or maybe on a shared Google Drive. And then the data is far more compact. It doesn't need to be extracted from the database anymore. It's really on your hard disk, so to speak. We can even save, after all the measurements, the workspace to a MAT file, and then you have all the variables of all the components, all of them in function of time. You can do your own stuff with it. And in the end, that's the thing that is being used a lot now in the UK for the moment. You're not yet on holiday, apparently. You can save the live script with all the results in it, and that's what we are showing you in HTML format, PDF format, or in Word format. So what you see here is the result of a few clicks, I think, and the measurements. So we are, it will be after the holidays, Fabien, I think, but we will take a look at that entropy calculation, unless Paul or anybody else has another idea. Then it goes in. This should give you a good idea. I think we are now back here. What else do we need to test or say? Well, we are looking forward now that the connection is there to test the usability and the user friendliness, also a little bit the accuracy and the operational aspects of the whole thing, because we need to know if you are really using it in the cabinet of a physiotherapist or in a classroom for students. We need to know how you're going to use it so that we can have the correct parameters assigned to additional parameters assigned to an IMU or an EMG sensor or whatever, so that we know if we need to add additional data fields, because they need to be added in the database. In the app, it goes quite quickly. Also in the DCU, and there it is more hard coding, I guess. So it's better that we take a look at things like this in time. For the rest, we are looking forward to your suggestions for the basic analysis, which is, I repeat it, measurement by measurement. But you can combine, of course, in MATLAB, or in the case of Martin Houry, he was a candidate for it. You can also analyze, of course, data in the database, not so much for the calculations, I think, but for the combinations. Select me all the patients with this and this property, if I may call it like that. What do we get, and etc. That kind of queries are to be done by the data analyst. That is not something we're going to provide. This is about it, I think. It was quite quick, but the next time we can, I hope that we can discuss already a lot of measurements streamed to the database and analyzed by the live script and maybe by the data analysts if I hear that sensors are being sent out, then I think that measurements can come quickly. This morning, the project officer asked how many downloads there were of the app. Well, only a number in France and Belgium, I think 9 and 3. But it is not in the App Store. You can simply download it. It's also on GitHub, but for normal user, I think it's better that you use it directly from the App Store. You need, of course, it's an ongoing question already for a number of weeks. We expect also lists from you of users so that we can provide you logins and patient and researcher IDs, etc., so that we can prepare. So the ones that really want to use it in clinical trials or extensive testing with patients, I think Fabien was going to collect that. Correct me if I'm wrong.
Yes. Yeah.
Once we get it, it's just a matter of setting up. So
okay.
We are here. The connection is established. We are a little bit in known territory. From now on, I think that the changes and the testing from our side now can really go very quick. The only point is we need to know what to do. No doubt you're going to say that
yes.
during this slide. If there are any questions or remarks, we are glad to try to answer them.
Okay. Thank you, Philippe. Are there questions, I would say, mainly from people external to NOMADe first? Okay. Are there questions? I see.
Martin?
Martin, ouais.
Yes, thank you, Philippe, for your presentation. It was really, really nice. I have a question about the data access you said earlier. Is the database live? I think you said yes. And
yes, we could say that again. Yes.
yes, it's live. And when do you know when there will be real data from IMU?
There is already real data from IMU when Sarah is testing. She's streaming. Sarah and her colleagues are testing. They are now part of their time streaming data. You saw measurement 88, I think. It means that there were 87 before.
Okay. So
you can stream data if you want. If you have sensors, if you have a DCU, you can install the app, connect, and in fact, you can
store it. Okay.
Yeah, it's completely live. It's already live for a long time. Since the moment that you have the questionnaires available, all the rest was also already there.
Yes, and I already have an access to the database, so I have all I need. Thank you.
Okay, and for the list you asked for, okay, I think the list, maybe it exists already and I forgot to send it. It's possible, but I will check with Paul and you will have this soon. Maybe if you want, yeah, I know Richard said we could come back to the main discussion now, but we have still one presentation with Wesley, so we could move to your presentation.
Could I maybe interrupt? Yeah. It's not a question to ourselves, but we followed the discussion without interfering after the previous session about the distances and stuff. I think that we more or less experienced the same here. Keep your distance a little bit. A few meters can do wonders, and not too much meters, Paul. That's also not good. You wanted to have something mobile. In fact, the system that we've been using in another project is completely mobile. You are driving a powered wheelchair inside, outside buildings, in elevators. But as it is now, the only drawback is, of course, we are drawing power for the data capturing unit from the battery of the powered wheelchair. So if you can solve the problem or the duration of the life of a battery powered DCU, then, and of course,
I think Philip, that is actually not a problem.
Yeah.
It's the problem is not battery powering a DCU. The problem is that then somebody has to carry around the DCU on a wheelchair. Of course, it's a different.
But it depends on the size of the DCU, and I don't know what the battery would be, but the smartphone.
No, I think it's not a problem.
The smartphone is already. Yeah. Could I finish the sentence, maybe? Thank you. The smartphone is already carried. It's quite a weight. So that one you already have. If you get it in your smartphone in a mobile way, or if you stay in the same room and the distances are not so large, then it is already mobile. Depends a little bit on the range. First it was in one room, then you extend it to everywhere. Extending to everywhere, you get into problems with the DCU. That's for certain the case. Okay, I interrupted you, but I wanted to finish the sentence.
Good. Okay, if there are no further questions, we can welcome Wesley.
Yeah. So I will directly go in the demo. I think it will be faster. No, I will share my screen and I will share what I see in my headset directly. So you will see what I see actually in the VR headset. So I am turning on the sharing. So normally it is started. I don't see anything for now. Yeah, I am not on the same Wi-Fi, maybe. Yes, I am. Okay, I will retry. Do you see something on the screen?
No. We see that you should start. Yeah.
Yeah, I see a loading screen in the headset, but nothing is coming. I will try another thing. So I have something in backup for that. We'll try with this thing. Okay. Okay. So no, I don't see anything.
No.
Stream.
Okay.
Okay.
Thank you.
No, it is okay. So I will start the app directly. So did run VR. So just to everybody, the the main goal is to reproduce the clinical test DIDREN VR, the DIDREN clinical test inside the VR environment. So this test is about evaluating the cervical mobility of a patient, and we have in the real test some targets. Like this, in real test, we have targets and we need to shoot them with a laser on the head. In order to validate a target, we need to stay inside the target for some time. It is the validation time. And we need to do seconds like this, shoot one target and pass to the next one, etc., etc. So this is the classical test in real, and here in this app we can do this test in VR, but the main thing is we can also do other tests. So as you can see here, we can choose other position of the target. So for example, this one is just a triangular shape in order to observe other cervical rotation of the patient. We can also here select and modify all the parameters of the app. So the main are in the center view, so the validation time, the number of cycle, and here the accuracy, so it's the size of the targets that you need to shoot to validate them. So for example, I will put one. I will just put one cycle and 0.5 seconds. Here you can select the starting side. So first it is the center target, but you can choose left one after, right one, or randomly left or right. So here I choose randomly. The room size. So for now I am in the normal room. It's the first one that was developed, but for some parameters it is more convenient to use the tall one or the adapted one. So I will use this one. And the last part is about the background. So for now it is the neutral background, but we can select some image to put behind. So this was one of the things we wanted to use, and we can also select the color of the image or of the neutral background if we select the neutral one. So I will choose this one and do this test, for example. So now you see the difficulty. The accuracy for sorry, it is 1, so we can shoot in any part of the target. It is more easy. But if I put 3, for example, so the circle is reduced and it is more difficult. So it increased the difficulty. Cycle number is just how many targets you have to shoot. So one cycle is 4 targets, and so you repeat the same cycle how many times you selected in the cycle number. During all these tests, data are saved into some files, and we can analyze these files after the test. So I will show you briefly what it looks like on the computer. So I will cut this part and I will show you this one. So this is an app I'm using to manage the headset, so to share the screen and to get the file back. So I can go and select the data from the headset. I will save to my computer, and now I am able to go and see all the data, so inside these folders, and I can see what I made in this small demo, so which test I made, which room I used, what was the starting side, how many times I did these tests, and all the rest of the parameters. And for each one, you have two data file related. One is about all the data, the kinematic data, so like an EMU, acceleration, velocity, position, and all the angular stuff. So you have all the raw data here, and you can make graphics about. And another file here is about all calculated data. So mostly about minimum, maximum, mean value, and timing value. So here, all minimum, maximum, and mean of the kinematic data. Here you have all the targets, the enter time, leaving time, the shoot time, and the reach time. So reach time is the time from the previous target validated and reaching the next target. And here you have all the min, max, and mean value about these data. So with all of that, we can observe and see how a patient is doing a test, how it is the difficulty for him, and adapt the test for his capability. Because it is one of the things we want to do here, is to adapt the application for the patient and made the application the most efficient and practical as possible for the kine. I finished this presentation, so if you have any question, I am here to answer.
Thank you, Wesley. So, does anybody has a question about what we just have seen? Frédéric?
Ok.
Tu essayes de parler?
Okay, no. Maybe if there is no question, I invite you to return to the general room for the concluding of this afternoon, and see you there.
Thank you all for your
Bye
participation.
bye.